Hey, good morning everyone. It's me, Yuri, and we're gonna code some stuff today again. Well, let me know if you can hear me well. Let's get started. Morning everyone. Yay, yay. Gonna be drinking some wine again. Something small this time. Just to get a bit warmer morning. Okay, let's get started. So, had a couple of ideas. I had a couple of ideas for this stream, but then a couple of days ago, like the day before yesterday probably, or even yesterday in the morning, I saw this GIF. Gonna switch the screen now, by Jun Nakauchi. Hope I'm pronouncing it right. It's real amazing guy. He does those GIFs. He usually does them with the open frameworks, and he did them for like 2 years already. And he's from Japan, and I advise you to go follow him, and you can read something about him on Japanese, obviously. Yeah, Chun Nakauchi. I hope I'm doing this right. So when I saw this GIF, I kind of wanted to recreate it with a three.js. Yeah, hyvä huomenta, Sebiton. Because I think it's beautiful, not only because of the colors, but the idea, I like it, and the cubes and all this stuff. And also I wanted to try gsap recently, so I thought I maybe could combine those streams into, because this animation looks kind of simple to me, but it has some nice things inside. So today I'm going to be using Canvas Sketch, just because, I don't know, because I want to create a GIF later on from this, and it's easier. So it's Canvas Sketch by Matt Delorier. I'm gonna look for WebGL example of the Canvas Sketch, and let's start it. Yeah, 3.js basic code. So I'm not gonna be using any starter templates today. Everything is just Googled. Okay, maybe I should just do it like this, and then I should call it pixels, like a 3D pixel. Okay, I already have pixels on my desktop, like a 3D pixels. Okay, because my disk is full. What the hell? My disk is full now. Okay. And then I'm gonna just open it in and call it pixel.js and just put all the code there. Your daughter's account. Okay, so she's gonna be subscribed to some technical stuff. Okay, so there's a basic 3.js example that Matt Delorier done for the 3.js. It just sets up the camera, scene, some cube here, and then it just animates all the stuff here in the render function. Yeah, like that. Okay, let's see if it works for us. I'm gonna go to 3D just pixels. I'm gonna run Canvas Sketch pixel. Let's see. Should be missing some dependencies probably, but I don't. Okay, is it just working like that? Just like that? Didn't expect it to work that fast. Well, something is wrong. What is wrong? Why isn't it showing me anything? What the hell is happening? Okay, maybe I should probably install the things that would be missing here, Maybe that's because I don't have enough space, so I'm gonna go and delete something that takes a lot of space. I probably have the movie here, which is 18 gigabytes, which I already seen. Do you have an HTML file for that? Well, now I just googled the example. No HTML file needed because Canvas Sketch actually creates it on the fly, and yeah, you don't actually need to create HTML file. You just need to save JavaScript file, and that's a good thing. It's like the processing file, you know, you don't have HTML, you just have the drawing code. So maybe I was just missing, yeah, no space left on device, obviously. Saying it to me the whole time. Yeah, I probably need some more wine. Still not working. All right. So let's install the dependencies. And hopefully I have space now for that. Yeah, shoot. And then Canvas Sketch Pixel. What the hell is happening here? This is just the basic stuff. It should work. Didn't expect problems that soon. Expect them like 5-10 minutes later on, but not right now. Sketch. Okay, maybe if I just run it from my template. Is the file name? It's pixel.js. Okay. It should actually at least warn me about something. What the hell is happening? Yeah, I think I had some tests which I tried to test previously. Let's just try this one. Maybe because I ran out of space and something broke up with the node models, etc, etc. And in test, I just call it test. Okay. Okay, for some reason, Canvas Sketch just couldn't create something new because probably I ran out of space and some glitch concerning that one. Probably that. Doesn't really matter as I only have the basic code in this test code anyway, so let's open that up. This is just the same damn file, which for some reason works from this folder. You know, this is life, this is front-end development. It's happens the whole time. All right, so we have this cube, it's working. It doesn't have any HTML, it has only like Canvas Sketch dependency, and then we have some settings for this scene, for this whole animation, I mean, which is the WebGL context, and it's animatable and it's anti-aliased. And then we have the renderer and the camera and the controls and the scene, all this stuff. Okay, and then we have the rotation. We could just multiply this by 5 to see it rotating much faster than it was rotating before. So it's all good. It's all good. So first thing I want to create, I want to just show you how this new gsap feature works, because I wanted to try it myself, because I hadn't had a chance in some of my live projects to try it on. So I'm gonna create meshes. It's just gonna be the array, and then gonna just put this array like in a double loop. Let's make hundreds of those. 100, just 100, not hundreds. And then I'm gonna be creating this mesh in each my loop, and then mesh position. It's gonna be x equal just I, and mesh position y equals j. And then I'm gonna be adding those meshes in this loop, and should probably see the grid of the cubes. But because the camera is too close, I think I'd rather move it away a bit. Yeah, so it's actually a grid of cubes. Maybe I should rather change the z coordinate for the, yeah, and then maybe I should, yeah. So it's kind of centered now. So I have this grid of the cubes. I could probably multiply this by something like this, so we see it's really a grid. Drinking from the closed bottle of wine. Okay, it's actually kind of nice to drink wine during the coding. I think it helps a lot. Should drink more. Wouldn't even have these kind of problems. So what I wanted to try the new gsap feature, which is a stagger, but it's now two-dimensional stagger. So I wanted to go to the stagger. I wanted to, so if previously I needed to do something like this, it's not like that anymore. Just import gsap from the gsap. It's easier than it was before. Yeah, thank you for this emoji. Hope you're drinking wine too. So now they have this two-dimensional feature for the stagger. It used to be, I think you could have actually implemented that one with an old stagger too, but now they have it like feature. So let's try to animate something. We have now gsap, probably it's installed there, and we can, when the scene starts, you can just do gsap2 meshes. It's just gonna be the array, and then usually we had a duration here. It's not like that anymore. We just have a separate property duration. And then I wanted to, like, each mesh has a scale. Like, let's make it like that. Mesh scale 0, scale, and then x equals 10. Let's see if that works. Cannot find my gsap. Okay. Let's install it. What the hell? Now this one wouldn't work. Property scale of undefined. Meshes scale. I'm not actually putting anything into my meshes array. Mesh. Yes, now I have this just one of the cubes being scaled in one of the axes. So it's actually work like that. All right, so we can scale the cube, but what I'm more interested in here is the stagger animation. So we can actually set up this whole thing as a grid. It's going to be stagger grid. I have a grid 10 by 10. So let's make it 10 by 10. From center. Okay. But I need to animate the XYZ property of the of the element, but I actually have it scale. How do we go about that one? We could actually, instead of making an array of the meshes, we could actually make an array of mesh scale objects. And that way, I could just use this array meshes here, and this is array of the scales. So each of the scales now has XYZ scale thing. So we can actually scale it to something small. Let's scale it to something small, maybe like not that small, a bit bigger. Okay, I just changed the grid size, but instead I should have changed this scale. Yay! So this is the grid stagger thing. So now we can actually animate it from, like, we can set the basic scale, for example, scale x equals scale mesh scale. C equals something small. And then we could just animate it to 1. And we're gonna have this nice, beautiful animation. Yeah. So this is like the most crucial thing that they changed in the gsap, actually just moving duration here and changing syntax slightly. So the other thing they changed, if I wanted this animation to be infinite, I want to create gsap timeline, because this one is like twin max 2 or something like that. You cannot link those animation into one timeline. So instead you need to create a new timeline. So yeah, it's like gsap 2 is just a simple one, stagger is also just a simple one, but you can make timelines. And to make a timeline, yeah, where do they create? It's just a gsap timeline. So let's do that. Let's just try it. I'm gonna make it -1, repeat delay 0. I'm gonna make it yo-yo true, which means it should go back and forward of the whole time, infinitely. And then I'm gonna create let timeline equals gsap timeline, and then just timeline 2. That's it. Should do the job. Let's see. So it goes one way and then it goes the other way. Somehow yo-yo true doesn't work for me. Well, just goes one way. Or maybe I should set the yo-yo true here. Better. Yeah, works like that. So I just wanted to show you the basic stuff about the gsap thing. This really nice feature. I don't think anything else changed much. This is just simple stuff. But anyway, so let's get back to the GIF I was starting from, this one. For this one I would need some shaders. So I would create the folder called shader. Inside of that I will create fragment JLSL. Oh, I didn't do that for a long time. Just writing shaders from scratch. Why not? I wouldn't write the the vertex one because I don't really want to do that. Vertex JLSL. I'd rather copy it from one of the previous streams. It's not really a complicated one, but any will do. Yeah, it's just a simple vertex shader, basic one. I don't actually need much of this stuff. Yeah, it should be good now. So I want to create one cube for now. I'm gonna go ahead and delete this timeline. I don't actually need all those meshes now. Too many of them. Just gonna be seen at one single mesh. Let's see if it's still here. Yeah, it's here. The camera might be closer. Yeah, so we have this rotating cube. Now I want to make this rotating cube be part of the shader material, not using the mesh physical material, which is beautiful, by the way, with a bit of a lightning. You have those shadows and all this stuff. But instead of this, I want to create new material. So let's be a new material. And what's it be? It's going to be shader material, because I need some shaders here, obviously. material. And I already have the shaders for this material, so I can just create a vertex, which is gonna be something that I'm gonna import from the vertex shader. So const vertex equals just import vertex from shaders vertex. Okay, yeah, because I didn't write it to the end. So let's continue with the shaders vertex. Fragment. Yeah, make all work for me. That is also true. I'm gonna need some uniforms here later on. Obviously the first one is gonna be time, just type float, and then the value just 0. Any other uniforms? I don't think so. Time just enough. Okay. I think this should be it. Expected. Okay, the comma. Of course, I can make a comma for you. Cannot find module shaders because it's shader, it's not shaders. Okay, it's good now, so now I can switch my material from the one physical based to this one. Now it's going to just write cube because I just changed the material. So the first thing I want to do when I saw this GIF, you see that all those cubes has some borders. So let's do the stuff we actually did in the previous stream and just add some borders to the cubes. Boom, 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 boom. So I'm gonna put up a variant here and just preview it if I still have it here. Do I though? It's a variant here. It should be also here. Why don't I see it? Why doesn't anything change? Do I have some error there? Oh yeah. It's not the vertex and fragment. It's a vertex and fragment shader here probably. Yeah, now it works, right? Actually, by default, it's showing me a red material somehow, which is coincidentally was the same color that I set here. So let's see if we have the UVs. We have the UVs. If we have the UVs, we can do some math and do some borders. So let's do the float border equals, let's make a width for that. Float width equals something small. Float precision, I would need the precision for my width, which is gonna be just something even smaller than that. And to make a border, I can just do step UVX. Let's make a border here. Step UVX, VUVX actually, VUVX, and my width. And we don't see anything because maybe precision is something, it just highlights it, so maybe I should make it press. Yeah, I think it was predefined variable and I couldn't actually use the precision named variable. So we have this border on each of my sides, but it's actually better to do this the other way around. So it's going to be width minus precision and width plus precision, and do a smooth step instead. So it's going to be roughly the same, but it's just roughly the same, but just a bit smoother on the edges. So I can make it 0.5 and it's going to be just half the edge. Alrighty, so it's border X, but I actually wanted this border to be from both sides. So to do that, I'm gonna do this. I'm gonna take the maximum from this same value, but 1 minus VUVX. Because I changed the name, obviously, and this comma doesn't need here. Okay, so now we have borders on two sides of the cube. So this was border x axis. Now I can make a border y axis, which is going to be the same, but just VY. And then I could make the float border, which is equal to the maximum from border x. Maybe there is a simpler way to do that. I don't know. This one works good enough. So maybe I should make the border a bit less than that. As I told you in the previous stream, there are a bunch of other ways to do this same border stuff, but I kinda happen to like this one more because it's easy. You just set up your own material, you're in control of everything, and you just change anything you like. Alrighty. Let's move ahead. So the next thing I'd rather do, yeah, it's in English now. Maybe I will make some streams in Russian, but I don't quite see the point now because everybody who's in chat now and speak Russian, they're actually watching me speak in English, and hopefully they understand me. So, but by making them in English, actually more people can watch them from more countries, and etc. etc. I kind of want to spread the knowledge not only in the Russian speaking community but all over the world. Okay. So I created the cube with the borders. Now I want to create thousands cube of the with those borders. For this I would need the mesh instance material. I think it's called like that. Free mesh instanced, just free instanced mesh. Yeah, it's called. For that I would need to create the number of those meshes. I still have the material, still have the geometry. I'll create something called like the count, and the count's going to be equal, let's say 12. So I want to create the grid. One dimension of that grid is going to be 20. And then instead of creating instance mesh, it's right here. I have the examples here somewhere. The raycast, yeah, I want to create something like that. Instanced. Yeah, you just need to put a count. So it's not going to mesh, it's going to be 3 instanced mesh. Material is going to be the same, but I'm going to have here the count not the multiplied, but squared, because I want to make the grid 12 by 12. And then to make this grid, I actually need this dummy objects or transform. How do they do it? Yeah, it's right here, just some dump object, which I'm gonna be using just as API to create the matrices. And then inside of this whole thing, I'm gonna do this. So it's for I minus count. For j count 2, I'm gonna do this. So the mesh is now instanced mesh, and it's still mesh. And then it's gonna be something like I because called 0 because it's some other index. And then offset. So let's call it AI, J, and then 0. Should be good. So we're creating 400 objects now with the instanced mesh. And for each of them, we set up the matrix. And by the way, for that matrix to use, should add this one here. And hopefully we would have a grid of the cubes. Yeah, we do have this grid of the cubes. So let's just move camera a bit away from Maybe I should make it z coordinate, just like I did before. And maybe also I should minus count divided by 2, so it's centered. So now we have this grid of the cubes with the borders. Almost good. But I need to do something more. I need to put the camera away. Yes, now we have these grids of the cubes. It's all good. And hello to friends. Yeah, that's one of the reasons I wanted to make it in English. Also to practice my own English, because I kind of wanted to try myself in a public speaking in some other conferences. And like the only conferences you can speak Russian are actually in Russia, Ukraine, and maybe Belarus. But the world is a bit bigger than that, you know? And by the way, I'm gonna be speaking at the Budapest Jazz on 19th of March. Yeah, so the next thing I want to do, I want to create a couple of other layers, because as you remember this GIF, we have some more layers, like at least six layers of this stuff. So let's multiply it by all. Let's make a cube out of those. So it's gonna be cube now for this count. And we have another loop here for the k variable, probably k, and then like let's make it in order, like kjk, ijk, and it's gonna be the same but for the k. So now we have a cube of cubes. That's already kind of nice thing to have in your everyday life, you know. It's useful to have cube of cubes. What is also useful to have in your everyday life is a wine. So you can do a bunch of amazing things with that, actually. Like for example, instead of rotating the camera the whole time, I can maybe just rotate it 45 degrees. Why the hell it's not? Oh, because the camera position is somehow distorted. Alright, but that's good. So now we have this whole thing, and I want to create the attribute, because I want to use coordinates of my objects inside of my vertex shader. And for that to happen, I think I need to create the attribute. So first of all, I want to create the something called boss. Let's start with the random. Something called random. It's going to be new float array, and the same thing. Cube of the count, and then kind of want to fill this array here. So it's going to be random, same bar, just math random, just something random, and then can use it, I can attach it to my geometry. So it's going to be just geometry, which is, I'm actually using, okay, I should let geometry equals box buffer geometry, buffer because I need to add the attribute, and then set. This autocomplete is not helpful at all. So I'm gonna name this attribute random, and I need to attach it to my geometry. And for that, because this is instances, it's gonna be instanced buffer attribute. And this instant buffer attribute is gonna be using my array just created, which is random. Where is it? Random, and it's one value per object because it's instance buffer attribute. So it's only one value per object, and now I can probably use it here. Attribute float random. So I'm gonna create the vector new boss equals position. and I just multiply it by random. Multiply all the values by this random value. And we see kind of nice picture already. So it's all the cubes with a random size. I think this time it's going to be a bit more beautiful if we just bring the rotation back for a moment. So you could enjoy this whole randomness of the cubes. It's kind of beautiful already. You can call it a generative art. It happens all the time. Or you could just make this beautiful thing and show somebody and print it. But I want to create something better than that. The other thing I can create is actually I can add some colors to the cubes. Right now they're just having the red border, and I happen to not quite like that. I want to create something cooler than that. So I have this border value, which is 1 where on the border and 0 everywhere else. So I'm going to create final color equals mix some 2 values with a border. And the first value is going to be just white. And the second value, let's just, I don't know, I'll just take some of the colors here. And I'm using the color snapper, an amazing thing which allows me to change the color format to anything I want to. So yeah, now I should just use this final color here. And now we have the white, because I should probably change the places for these two. Now it's going to be blue squares with a white border. Okay, make it a bit thicker. Yeah, it looks kind of nice. See, next thing I want to do, I need something that looks natural, and I also need some coloring. So these colors, if you look closer, they actually should remind you of something, and this something is called HSL. So these colors are made with HSL. And I think I should have GLSL, HSL to RGB thing somewhere. So it's just what? Just a function that can, okay. With which you can set the color with the HSL. There's no built-in thing to set HSL colors in GLSL, so I need some helpers for that. And again, this function was by Gem3, but latest edition by Matt DeLorean. Okay, so now we have this function. It gets 3 variables like hue, saturation, and lightness. Oh, what's that? And now I can use these colors to colorize my cube. So for that, I would add another variable here, which is going to be like something called depth. Yeah, let's call it depth. Depth, same amount of values. Depth is going to be just j divided by count. So it's going to be from 0 to 1 again. And then I'm going to add this depth here. So now I have this depth here, but to use it to colorize something, I need varying. Depth. Now I can use it here. So instead of using this blue color or something like that, I can use vdepth. It takes 3 arguments, and the first one is gonna be vdepth. Let's see what we're gonna see here. Okay, something's probably wrong with the shaders. No matching related function found. The depth function expected. It's not vdepth obviously, because it's HSL to RGB function, which takes those 3 arguments. Yeah, now we have this amazing, beautiful HSL gradient here. if you ever saw this one, this is just HSL. Now I'm not sure which part of this gradient Jun took for his animation, because I think this part where the blue and the light blue happens and the purple one, I think it's closer to that one, but that's not it. Okay, also the other nice thing that you can do here, we actually have something called time here. So we can do material uniforms time value equals time, and now in my vertex shaders I already have this time, and I can just multiply this by ups sine time divided by 4. Let's see what's gonna happen. Yeah, so now they're just gonna be oscillating from 0 to 1. That's not cool, but we can just add something like position x plus this. Guess it's too small. Let's multiply it by 10. Now we have some weird animation. We're only changing the scale of some values because it's position. But what I actually need, this position now is the position of each of the vertex of the cube. But what I really need is the position of each of the cubes. So for that, I would need to add not the variant, but the attribute called pos. Because right now I have this position here inside the instance matrix, but I'd rather use it separately. So I want to create the pos. It'll be multiplied by 3 because it has 3 numbers for each of the vertices. And then I need to, I need to create this thing here. For that I will add just another jj variable, and it's gonna be like that. It's gonna be pos jj equals just I divided by count, and then jj plus plus, then j, and then k. So it's going to have 3 numbers for each of the vertices, and then I can just add pos here, pos, and it has 3 values for each of them. Should be good now. So instead of using the position, I can use pos here. Now I'm gonna see the sine function in the volumes, you know. So I think I'd rather move time faster. Now those cubes, I think maybe I should remove the rotation for a bit of the time, so you see how the sine actually works in the volumes kind of thing. And then I could actually do some weird stuff like this. This is kind of experimenting stuff, so each of those could be a chief or something. Not goes into the volumes, maybe not 10, maybe just 3. Now we have this weird kind of animation. I think this actually looks like one of the examples on the three.js website with the circles, but still you kind of see how you can get there with those simple steps. So the next thing I want to do, I want to make the coloring just like in the GIF. And for that I'm kind of having a problem there. Maybe I should dig a bit. The code for this thing is actually open source, so you can try and play with it, but it's in open frameworks. But I think I can take the color part here. It should be somewhere. You can see that the syntax is completely different, but it's kind of on the same. So it's HSB, but it maps not only hue but also the saturation part. Okay. Let's try to use bdepth there as well. So I'm gonna go to fragment shader and let's try to do this. Okay, this is moving more to the red color. Requires a bit of a play in here. So he maps this thing to this range and the other thing to the whole range. Let's see what we have if we just randomly change all the values. Maybe we just come up with something that looks cool. I think this is actually looks kind of like what he did. Not exactly, but kind of a bit on the other coloring side. So maybe something like that should help us. This is a hue. We should add the saturation that way. Yeah, I think we're getting there. It's not the exact range he used, but it's kind of like that because it's lighter on the top and then it gets. And also I think I'm using the white shader now, but I'd rather use something gray. And something gray is just all the same values, but smaller than that. It's gonna be gray. I think it's too much of too dark now. Maybe just like that. Yeah, I think it's good. It looks kind of white on all the other cubes, but good. Next thing I want to do, we kind of want to make this cube even bigger than that, so it looks like a surface. So for that, I'm gonna just not divide, but multiply my count by 3, and let's see, do we still have those FPSs? Kind of lost them already, but it looks cool, right? Maybe I should move the camera a bit away and it's gonna be better this way. Yeah, we still have those 60 FPS because it's just, how many cubes do we have now? 60, 60, 60, just 200,000, all right. Not much of a cubes, right? And the last thing I want to add here is GLSL noise function. So let's calculate this noise algorithm, and I want it to be 4-dimensional. Okay. Thanks, David. I think you're right. I was just kind of throwing random values, hoping that I'm gonna get there. I'm not sure I have the full feeling of the HSL function, like where do I move it so I get the exact colors. So I came here for the 4-dimensional noise function. Let's just use this one. I'm gonna use it here. And this 4-dimensional function is sNoise, which takes a 4-dimensional vector. So I'm gonna calculate the noise. Noise equals sNoise. It's gonna be vector 4 here. So one of the values I'm gonna use is the position. So the noise is going to be dependent on the position, and the other value is the time. This is a vector 3 and this is a float, so together it's going to be just what I need. And I'm going to comment this part, and I'm going to multiply my scale with the noise now. And I don't see anything because I probably threw it somewhere. But where exactly? It's GLSL error and too many arguments. 156, which is why is it too many? this position should be... Oh, I wonder how it even works that way. So now we have this simplex noise thing working on the 3D space. I think we'd rather make it a bit smaller and the camera closer. Camera position. Where the heck are you? Have this cube, and I think we'd rather move time slower. Time. Getting lost in the code now. Time slower. So now we kind of have this thing. I think we should multiply this by 3 maybe. So now we have those volumetric areas of where noise is like bigger than 0.5 and where noise is small. So now I can do something like this. This is not a good thing, but I can do noise equals step noise 0.5. So it's going to be just 0 or 1 now. If it's bigger than 0.5, it's going to be 1. If it's less than 0.5, it's going to be just 0. Now we're gonna have those holes inside my objects because like I'm hiding them with the vertex shader because I'm multiplying all the vertices with 0, which scales object to 0. Now I'm not sure it's a good way to hide an object in GLSL. I think we also need kind of more holes here. I want to make them bigger. This way we're gonna have more holes. Yeah, so it's kind of what we were hoping to get there. That way you could hide an object here, I think, is just making another variant, which is gonna be variant v hidden. And just do the, oh, it's not here, well, I mean here too, but I'm gonna put it here, variant v hidden, and this v hidden is gonna be equal to this noise, and here we're gonna have like if v hidden is less than 0.5, discard. So now multiplying here should probably look the same, but I think it works a bit faster this way if you discard it in the fragment shader, not in the vertex shader, because this way the vertex shader still does something to the vertices and the fragment shader still tries to draw this small thingy on your screen, like even if it's 1 pixel. Well, that's just what I'm thinking. Yeah, I think it's that. We could bring back the rotation here, not the 5 times though, just a small rotation. Another small rotation. So now we have this cube. No, I'm not in Russia, I'm in Kiev, Ukraine. And this is 2 different countries. Alrighty, maybe I should make the holes a bit bigger, like that. Yeah. Maybe we could play with the timing here. I don't think it's fine to use 200,000 of cubes on your landing screen. But I think if it's just a couple of thousands, should be good. I don't think you actually, I don't think even I need that number on my screen right now because I don't really see all of them. I could easily like make it less than that. I could make the count. So I could make it not cubic, you know? I don't actually need for this kind of GIF, I don't really need it with a cubic. I needed just the flat thing, like 2020 and then 6 layers. Why language programming? What do you mean by language programming? What exactly do you mean by that? GLSL? Like, you mean what language programming? Okay, this is GLSL, yeah, shader. So yeah, now we have this QB thing. Maybe if I make it... okay, let's make it bigger than that. And then move camera a bit further. I'm just trying to get a bit closer to that look, but I think, well, you got the idea, we can get there. Probably remove the rotation now. And then the camera. Where is the camera? Should make the noise a bit more interesting. Maybe this way. No, this is the other way around. Not gonna have much of the holes. I think maybe also, no, this is perspective. It has a perspective. Kind of want to play more with the noise function to get this exact look, but otherwise we are there. Yeah, just now we have too much of these 3 dimensions here. And that's it. I wanted to show you how to create this simple animation with the cubes that has some borders and this kind of stuff. Hopefully it was interesting to you. It was about gsap and 4-dimensional noise. And this is the reason you need 4-dimensional noise to create such things. Make it a deep sea of the cubes. Maybe time should be slower. Yeah. I should also make the last layer of the cubes always untouchable, so we wouldn't ever remove it. And I think that way we're gonna get to the animation. Yeah. How can you do things like this? Just follow the code. It's not much of a code we did today. Mostly just copy pasting. It's the simple stuff. I just wanted to create the real simple stream because some of them were quite complicated, like the ones before where I used lots of too many instancing and shader stuff and math and all the things around. So this is kind of a simple stream, how to create the ocean of cubes. So if you have any questions, I'm gonna stick in the chat for a couple of minutes, and otherwise I would wish you a good day. Not so sexy. Yeah, I could agree with you. I think we should play more with the colors and with the stuff, because I didn't really get to the final point I wanted to get, because this is all kind of experiments and stuff. So it's plenty of space to play here still. Yeah, I think I need to play with the colors a bit more. Why we should do such things on three.js? Because I'm a web developer, you know, and I can use it in websites. And actually, it doesn't really matter where you create those. Once you get a grip on the algorithms, you can create them anywhere. It doesn't really matter if you create them with open processing, with the P5, with the processing, with the JavaScript, you name it. Just doesn't really matter what's the technology you use. It's all about the algorithms. But because I like JavaScript more, it's more natural to me to use JavaScript. I kind of wanted to do this. Maybe I will switch some at some point. So okay guys, have a nice day. See you. Live your life happily. See you next week, hopefully. See the announcements.